Good evening, friends. So, I have been asked many times about joins by a lot of SQL developers, and it has been like redundant times. I have explained joins. So, for the benefit of all today, once and for all, I have decided to shoot a video with a very simple demonstration of the various kinds of joins that we have in SQL Server. So basically, if you look at joins are nothing but they are a way of combining number of tables, more than two number of tables based upon a condition, a logical condition, which creates a subset of a data. I mean, it could this subset of a data could be used for inserting into another table or for any other further DML manipulations that you would need. So basically there is a logical condition which we will be looking at, based upon which you can join several tables. A lot of developers are not very comfortable writing joins, but because of the complexity of the understanding that you need to have. But if once you are comfortable with the various kinds of joins and the scenarios where you would use them, it is your T-SQL coding or T-SQL stored procedure coding becomes very easy and simple. And also in terms, the SQL Server understands joins pretty well. So if you can write joins within your T-SQL statements, it's a really beneficial and also efficient. So let's take a look at this important uh, concept that we would be it's really important for you to be well versed with this join. So basically what I have here for this session is I have created two tables, a very common one, an employee table and the department table. So the employee table has an employee ID which is of int type and primary key clustered, and then we have the employee name, the employee's corresponding department ID, and the corresponding manager that the employee reports to. So and next we have a department table which has simply two columns, department ID and department name. So our department table contains, if you would it has few departments, which 5 departments to be precise: finance, IT, HR, admin and infra. They are all fictitious data that I have inserted, and my employee information is stored in my employee table, which is as so the employee table is containing your employee ID, employee name, department ID, and the manager ID. So basically if you're looking at the data, if you look at employee ID 1, Keshav, the manager ID is 1, which means that he doesn't report to anyone but he reports to himself. But if you look at Alex, he reports to employee ID 1, which is actually Keshav. So likewise you have the data, Ricky, which belongs to a department uh, of HR, reports to himself, while Lee reports to Ricky. Next we have Freddy, which belongs to finance department, and Royal, who further reports to Freddy. So likewise we have, and we have a data where who doesn't belong to any department, but although it reports to Keshav. So we have Smith, uh, who doesn't belong to any department as of now, right? So with this data we will be covering joins for you in this session. Let's first understand what are the different kinds of join that we have. We have basically three main kinds of joins in SQL Server, which is inner join, or you could call it equi join. We have outer join, and then we have cross join. So basically we could segregate joins into this three segments: inner join, which is also called as equi joins at times, and then we have outer join and cross joins. So let's look at each of them in detail. So let's understand first let's try to understand inner join. That's how actually for intelligence to work you would write your queries like this: name, comma, rather department name. So that's your code for your inner join. So let me first explain before we see the results. In inner join, what happens is, in join generally you would have an on clause, which is the actual logical condition. So anything here, what you can see is we have employee table and the department table, and we have an on logical condition. So basically and with the employee to to understand, we have created alias objects. E actually is an object of employee type. It's for employee table we have created an alias. So basically we have E as an object ID, you could say, and the on condition is the logical condition on basing on which we are actually joining. So if you can see, there is this department ID which is in the employee table, and there is this department ID, d dot department ID, which is in department table. So basically it will search, our inner join code will actually search to match the department ID from your employee table to the department table, and basing upon the match, if there is one on one match, it will come up with the results. So basically what you will be seeing is the employee ID and the employee name of all the employees which have a valid department ID matching with the department table. Let me repeat, you will get the employee ID and the employee name of all the employees from the employee table which have a valid department ID match in the department table. So if you look at the results, what you would see is you have 6 employees and the respective department name. I mean which respective department name which are a match in my department's table. So your inner join is actually one-on-one match based upon the logical condition that you have. So of course you are entitled to write where clause in this. You can actually write where employee ID is greater than 3. So such where clauses can be written. So that's not going to be any issue, but based plainly this is your inner join. Let's move ahead. Next we what we call as a self join. So let me explain what a self join is. Right, so this is the code for a self join code, what you would call. Let me first explain what a self join is. If you look at this query, what you would see is we are having the employee table joining to itself, inner join to itself. So basically at times you would need to join with the same table. In scenario will be something like this. Basically if you look at the data of employee, what you would see is an employee and its manager ID is there. So basically if you want to retrieve the employees and their managers that they report to, I mean in the subset, so you would need to join with the same table. So in the memory what you would do is, in the memory SQL Server will create I mean a buffer, I mean tables, I mean two replicas of the same table employees. So and based upon your logical on, it will actually join the data. So basically if you see here, what you get is simply uh, the same table employee. We have created two objects, E and E2. So we are going to match on the employee IDs with the manager IDs, and based upon that we will actually, what we will get is, if you run this code, you would get is the manager's employee ID, manager name, employee ID, and the employee. Basically if you look at, Keshav reports to himself, but Alex, who is the employee, reports Alex's manager is Keshav. Such wise actually you will get for the others. So basically this is a self join, which again results, shows you the employee and their managers details. So based upon this join you can actually fetch the same results. You can use the on clause, will have the join on the same table but with the different columns. If you see, it's joining on the same table but on the different columns. So this would be a perfect example where you want to uh, create a self join to get the relevant results. So remember that it's the results which is important, basing on which you will actually drive the join you want to use. So this is an important way where you will actually use a self join rather than an inner join. So that was your equijoin, or your inner join or self join, what you would call. Next we move out to outer joins. So for outer joins, let's what you see is the first kind of the outer joins I have written. It is left outer join. We'll come to so the left outer join, if you see, is actually it will join two tables based upon an on condition, and it will give you the results of all the records in the left side of the left. Easy to remember would be, this is your left outer join. So anything which you write on the left hand side of this, the table's name, this table, you will get the results of all the records which are present in this table based upon your match, the on condition. Even if it doesn't match, let's just take a look at the result sets first. So what you see here is, in the left outer join you have a record which is Smith. Smith doesn't have any department ID match. The department ID is null, so you do not have anything. So you will get the record Smith, and against the data for the department data you would actually get null values. I hope I'm clear enough. So basically I'll repeat, you will get all the records which fall on the left hand side of the left outer join uh, of the table, and based upon your on condition. So and the data for the right hand side of the table in such scenario will be null. let's just take a look what happens in case of right outer join. And what's going on? So this is your right outer join. So basically, if you take a look at the result, you will see all the records from the department, while you will get against the records, I mean whenever there is no match, you will get null values. So basically here you won't get the value Smith as against your left outer join. If you this is the result that you have for your left outer join, you'll get everything in the department table, that is everything in the employee table, but not but you will get only those records in the department table which have a match, and anything which is there in the left hand side which doesn't have a match will get the value null. And this is your right outer join. You'll get everything, and the order, remember the order by will be actually of the left table and the right table. So in this left outer join, the order by will be in terms of the employee table. Your order will be in terms of employee table, while in this case in the right outer join your order will be in terms of department table. If you see, this is not in an orderly fashion. If you see, the order is in terms of the department table, so you'll get all the data in the department table irrespective of the records which are not a match. So you what you are getting is, actually there are two departments which do not have any employees, so you'll get the records of those two as well, but you'll get null values corresponding to them in the employee section. So this is actually important to understand, crucial to understand for you, that your left outer join will give everything from your left hand side of the table, while your right outer join will give everything in terms of the right hand side of the table. So this query is actually very good one when you are trying to do away with your in and not in condition. How, I mean, you can see, I mean, if you want to retrieve all the departments actually which do not have any employees, I mean, so what you will do is, so basically this would give you I mean, this is not in or a in condition. So basically you can do away with in and not in condition. So by use of left or right outer joins. So left or outer right outer joins are very good ways of, by which you can get the data which you are using, you would be using in and in condition or a not in condition. So here as you can see, you are getting the department names which are not having any employees to them. That's your left or right outer join. I hope you were able to understand. Next we move on to what we call is full outer join. So your full outer join will actually match everything, and it will give you the results of the complete, I mean, if you want the complete section of all whatever nulls, I mean, were there, it will give you null for its corresponding match. I mean, it's a union of your right and left outer join, if you will. So basically, you see, you can get a record which is not having a Smith, I mean the employee, which is not having a match in the department, as well as you'll get the department which is not having a match with respect to its employee. So it'll give null values wherever the match is not present, but it will give you the full complete data match, I mean as per the match. So basically, if you want to get all the employee details which do not have, even if which do not have any department corresponding to it, at the same time you want to get all the departments even if they do not have any employees present in them, this would be your join. Full outer join would be your scenario. Next and the last one what we have is a cross join. So cross join, remember, will not have any on condition because it's simply a cross join of all the records. Let me just show you. So basically, if you run through a cross join, it will actually be the cross multiplication of all the records. So basically, if you see, there are 7 employee records and 5 department records, so it will be 7 cross 5, that is, it will be your 35 records. So basically, each of the employees will be matched against each of the departments. At the same time, each of the departments, if you see, are matched by each of the employees. So basically, it is simply a Cartesian product that you have as the result. So this is your cross joins. So that's it in terms of SQL Server joins for you that you have. Remember, all the explanations that you have, I mean, you can use joins as a very easy way by which you can actually segregate use most of the indexes built on the table in the where clauses. You can actually eliminate subqueries with the help of elimination of in and not in condition by the help of your left and right outer join. And similarly, you can actually think of the logical scenarios wherein you can use the right kind of joins, and with them you can get the right result sets. SQL Server understands join really well, friends. So I hope you write your queries using join as many times as you can. So please go ahead and make the most of it with the help of joins. Thanks a lot.